Hi, my name is Gordon Beaming, and in this video I'm going to show you how you can use GitHub Codespaces to prototype an idea and put it into action, or should I say put it into actions, with nothing more than just your browser. So this idea started because I'm working on a project where I'm going to use the Strava API, but obviously instead of using the raw endpoints, I decided because they have the Swagger definitions published, I'm going to just use Swagger Codegen and generate a lib for that. If you go and Google around Swagger Codegen, you'll see that all the examples use Linux, and not that you can't do this on Windows, it's just a little bit more frustrating than I'd like it to be on Windows. So you're probably thinking, well, when you're on Windows, just use the subsystem for Linux on Windows, and yes, that would work. But once I'm done with this, I don't want, in this case, the source code for this lib to sit in my repo because it's not my source. It just feels messy and weird. So I want to create a NuGet repo or a NuGet library for this, and I wouldn't want to build that on my machine and then publish it to NuGet, especially because if their API changes, then I need to remember all those bits and pieces to set that up, and it just feels like lots of effort. So I thought, okay, well, I don't want to set that up locally, I want to prototype something. So I went ahead and saw, is there a Docker container for the codegen CLI, and there happened to be one. So I thought, okay, well, I could potentially look at putting this all into GitHub Actions, and then from there I'd have something that's in a repo that's rerunnable, and that whenever their API changes, I could just rerun and sort of make myself a new library for that. So I'm going to start off here. I'm going to go and create a new repo, and I'm going to call that repo, as with all my other demo stuff, and we're going to go and add a readme file, choose a license, and we'll just make it MRT, and we're going to go ahead and create that. If you haven't seen Codespaces, you should really take a look. It's amazing, or you'll see it now, but you should really go and see if you can play with it yourself. It's really cool. So I'm going to go ahead here and say I want this in a new Codespace. And yes, I could pull this all down to my machine, but I haven't been playing with Docker for a while, so I'll need to do an update potentially. And Docker updates are interesting sometimes, so I didn't really feel like I wanted to do that. And plus, Codespaces is amazing because it does everything that I'm going to need it to do out the box without me having to do much extra. You see, by default, well, you probably won't know, but by default this has loaded the theme that I run my own VS Code in, and the reason for that is because I've synced my settings with my GitHub settings, so everything works nicely for me, understands all my preferences and stuff. So because I'm going to, the way I'm going to do this is I'm going to run a docker run command and run the CLI, or the CLI command inside that Docker container, and then I'm going to go ahead and map a local drive so that obviously all those files can leave the container onto my drive, and then I'm going to build that out locally and then pack it up and push it to NuGet. But for that Docker run, I'm going to need some configuration. So I'm going to go ahead here, and we won't need that yet. So I'm going to go ahead and quickly create a config file. So we'll just call this config.json. And so the purpose of the config file is for the codegen CLI. So it takes in some args. So we've got a package name. We're going to set the version to 3.0.1. So that the target framework we want to use is version 5. We want to use the .NET Core project, and you can see the rest of the settings. I'm not going to go through all of them right now. Okay, so I'm just going to switch over to a PowerShell shell. So I'll just create a new shell, get some PowerShell, and then I'm going to allow copy and paste. You see I'm going to do a Docker run. I'm going to map this path, which is what we currently in, where our repo is mapped out or checked out to. I've just mapped it internally to a generated folder. We're going to use the Swagger API Swagger Codegen CLI image. We're going to call the generate command that's going to get passed into there. We're going to specify our Swagger JSON URL. The language we want to use is C#, and our output directory is going to be generated/g, and our config is going to be in the generated/config folder. So we'll go ahead and run that quickly. And while that's running quickly, if you don't know, by us mapping that internally to /generated/ where you can see, or where you saw that we were mapping it to generated config, it's actually our root config here. So where we told it to run, generate into generated/g, that's gone and put all the Swagger output in this folder for us. Okay, so our next step, suppose we could just go and look quickly at the code that's here. So you see there's the API with all the code that gets generated for us. We have client code and then models as well. The normal stuff that you would see if you were playing with the Swagger Codegen CLI. The next thing you want to do is go and create a CS proj. So I'm going to go ahead and create this CS proj, and to avoid all the typing, I'll just paste this in. So you can see from the CS proj what we've gone and done. We're setting the target framework to .NET 5, so this will come out as a .NET 5 library. Then we're setting the assembly title, assembly name, and the root namespace. Not that this really matters in this context, but I have it for me, I guess. Setting the version again to that same version of 0.0.1. Setting some settings that get used for the package. So we've got the package ID, the package version, who the authors are, the description that goes in there, copyrights and tags and stuff. Then at the bottom here, what we're going to do is we're going to tell the compiler to ignore if you go gsource tests. So we don't want, if we look inside here, we didn't even generate this with tests. So depending on, so this again is a habit for me to put in, but depending on what language you generated with, it would come pre with tests, which would be at a folder next to this called test. And then I know that this library uses these references. If you wanted to check what references it uses, you can go, I think, one of these folders, it was in the docs. So docs, what was it called? README. The main README file has the dependencies that you should be using. Okay, so I've just gone and put those in there as dependencies for myself. Okay, so the next thing I'm going to do is go and run a .NET pack. So I'm going to switch back to the terminal. I'm going to go run .NET pack on our CS project we've just created. So I'll go ahead and just close this quickly so it's clean again. So there's our CS project we created. We're going to run the release configuration and to an output folder called package. You'll notice when this runs, it's not going to work out as great as you would hope for it to run. It'll restore the first time this runs on the machine. It'll take a little bit while it restores quickly. But you'll see that it's complaining because it can't convert from an action type that's nullable to the action type. If we go look at the source code for that, you'll notice that action type in this specific API is actually an enum. So there's some weirdnesses with the way that generated. So because of that, I'm just going to go and do some code fixes. But remember, the end game for this is that this runs as part of a pipeline. So I'm going to go create a file called codefixes as a PowerShell file. And as you, in case you haven't picked up on it, this is all running in Linux land. And I am running PowerShell, and that's because PowerShell is now cross-platform, also if you didn't know, which is pretty cool. So I can use a language that's familiar to me anywhere I am, which just makes this whole experience that much more smooth, because at no point in this whole thing, besides when I sort of put that one path for the Docker run, did it ever feel like I was running not in my sort of Windows world, which feels great for me. Okay, so this little code fixes file, what it's going to do is it's going to say if this path doesn't exist already, so we're looking for from the path that it's running from, which we get from PS script root, we look for source, data, Strava, net core, and model. If that doesn't exist, we're just going to go ahead and create it. And then we're going to read in the detailed activity content. So if you remember back from this file that's failing here, you can see that that path is sort of the fixes path that we're going to go and create, obviously switching out G for fixes. And then the detailed activity.cs, you can see here that's that path that we're picking up. So we're going to read that file and we're going to replace activity type question mark with just activity type, and then we're going to save this to the fixes directory as the same sort of file name. The next bit of fixing that we're going to do, because you can see at the bottom that this also generates 2 warnings, and that's basically because it's an enum, there's checks in 2 places that check if it's not equal to null. Again, there's potentially something wrong with the definition of this API, which is causing it to do weird things like this. Or maybe it's the CLI tool. Either or, we're going to read in this summary activity.cs, and we're just going to add a ignore at the top of it to ignore that one error. And then again, save that to the fixes. If we had to go ahead and run our, so we just clear this. Oh gosh, that's not clear. If we go and run the same command again, though, this is going to break, because by default, the way that the new project system works is it reads in all files that it finds that are of the .cs type. So we're going to go make a small modification here, and we're going to say, actually, the same ways that we said ignore tests if they exist, and we want to ignore those 2 files from the generated path. So now when this project includes everything, it will take everything from the fixes directory. So if we go and run this locally now, so I can run this locally by pushing F5. You can see that there's now a fixes directory, and we have our 2 code changes. So this one's easier to see without scrolling far in the file and finding it. So you can see we added a little section on top of this, which if we go to the original file in models and we look for summary activity, that obviously didn't exist for the original file. Okay, so now we've got a code fixes that we've run code fixes. We've ignored that other those 2 files from our project. We should now be able to go run the pack again. Sorry, let's switch back to our other terminal. So we should be able to run this .NET Pack again, and everything should work fine. So now we've got a package folder here, and you can see we have a NuGet package file. So next step, we're going to go ahead and publish this off to NuGet. So we're going to go and create a new API key. So we'll just call the key that same name, make it valid for a day. I'm the owner for that key, allow the key to publish new packages and versions. We are going to label it, we'll narrow it down just to the specific package name that we expect it to come in with. And we go ahead and create this. Now we've got our API key, we can go ahead and copy that. And then we need to go into NuGet, sorry, not NuGet, back into GitHub, and we just need to go to our secrets here and store that. So we'll go to settings, secrets, we'll add a new repo secret, we'll call it NuGet key, and in case you are wondering, I did paste this key on the side so that I was able to repaste it again. Cool, so now that key or that secret is part of our repo. We don't have to worry about it anymore. So our next step would be, so at this point we're now ready to, like we've tested that everything works, we've created, we've generated our source code using the Docker image, we've built it locally using .NET 5, and then we've packaged it as well into a NuGet package. So we're going to go ahead and create our GitHub Actions file. Which I did a terrible job at. I thought that magic would work, but clearly it doesn't. So let's just delete that quickly and create this the long tedious way. So we create one folder, and there we'll create another folder, and there we're going to create a new file called update package YAML. Okay, so the next thing that we're going to do is go and drop all of our steps into that YAML file. So we'll start off with some basics on top. So the name of this is going to be update package, the same as our YAML file. We're going to allow this to run on any push to master this can run. Whenever we have a pull request into the main, sorry, I keep on saying master, into main. So when there's a push into main, this will run. When there's a pull request into main, this will run. And then we're also going to run this every morning at 5 AM in South African time. And then we're going to say that we are able to also trigger this manually. If I'm not mistaken, that's what the workflow dispatch little piece there is for. So that says that we're able to run this manually from inside the GitHub UI. Okay, so our next part is the jobs. So we're going to say that we want a build job. We've got a little condition here, and you'll see how this gets used later, but we say that this must run on the condition that the head commit message doesn't contain, so there's a not contains, skip CR in the message. This is going to run on a Ubuntu latest VM when it runs. And the first step we're going to do here is check out our repo. So the next thing that we need to do, because obviously if this runs every time, we can't have it generating as version 001, and the same in our project here, we can't package it up as 001 because that's going to have a conflict. So the next piece that we're going to do is set the version number. We're going to use we can use PowerShell as the shell that it's going to run, and we're going to run a set version ps1 file, which I'll go ahead and create quickly. And this file itself is also not too complicated, so we're doing the versioning using the day. So we're going to version by year, month, day, and then GitHub has an auto incrementing number for each run. So we're going to grab that run ID, just some logic for if you're running this locally. So it will set the run ID to 0 if it's running. Build up that version number, and then it will grab the GitHub ref, so it's the path to the branch that's currently running. Again, if this is running locally, we set it to local. If it contains a ref's head, we just go and trim that off, and then we say if it is running in main, our version tag is actually empty, otherwise our version tag is equal to dash version tag. So in this specific case, there's not many times where you would need to, or that you, in this specific branch or repo, that you would be branching out. But in the case that we do, obviously trying something random out, we want to make sure that any packages that get pushed with a tag that shows that they aren't stable tags. And then so obviously then our version number with the tag becomes the combination of that version number and the version tag. We go ahead and write out that information just so we can see it in the log. We've got a little find and replace method here, which will just read the file and do a standard find and replace, and then set the content. And then we're going to say read the config.json, and we're going to save it as a @-config.json. We're going to find 001 and replace it with that version number with the tag, and then we're going to do the same thing again for the csproj file, again doing an @ with that name. Okay, so now we've got that. Let's close these guys out. The next part that we're going to need, if we go look inside our actions for our workflow, is we're going to generate the Strava codegen API. So in the same way that we ran this in the console or in the terminal here, I'm going to just write out where the path is to this GitHub workspace. Again, more of a debugging thing than anything else. And then in the same way that if we look back to the path that we used here, we used the current path where we are running this example out of, we're going to pass in the GitHub workspace as the path to map, and again we're going to pass the generated folder inside of there, and the rest of this is going to look the same way. So we're going to use the C# language again into generate file /g, and then generated, but now we're using the @-config because obviously that's the one that's changed. It's got the updated version number. The next bit, if you remember, when we tried to pack, that code came broken for us, so we have to run our code fixes PowerShell script that we created to make those changes. When our project is running as part of the action, we need to go ahead and make sure that the version of .NET 5 that we want is installed. So we're going to go and call the setup.net action, and we're going to tell it to do version 5.0.102. With that setup, we'll now be able to run our .NET pack method, or command, and we're using the @-csproj, but the rest of this looks exactly the same. So if we look back down to where we ran that pack, we ran it like this. You can see it's exactly the same thing, it's just we've got the @ on top there. The next bit is so that we don't run lots of what do I say? We don't run the So obviously at the top here, like I specified, sorry, I lost my train of thought there. We can run this every morning, but we don't want a new package publishing every single morning if there's no changes. So our next method over here is going to hash the API content for us, and in doing that we're going to figure out if we do actually want to make changes every single morning. So if we go ahead and see what that looks like, I'm just going to copy it in here quickly. File name. Okay, so the file name will be hash API ps1, and we'll go ahead and paste this in. So in this case here, I haven't made this save the branch name. If you are going to, for some reason, do need any branching in your repo, you'd probably want to include that here as well. Because what this is going to do is you pass it a folder path and a place to save the hashes to. What it'll go and do is run through every file that's in that folder path, look for all the CS files. It's going to get a hash of each file, build up what that hash, what each hash looks like just with the file name, and then it's going to get the current hash of the file that's currently on disk, obviously if that file exists, and then it's going to write the hashes to that file. Just make sure I didn't overwrite something weird there, or change something strange. So that's going to then save the hashes to the file, and then we're going to get an updated hash of that once it's saved to disk, and we're just going to say that if the hash is not equal to the updated hash, we're going to return true, otherwise we'll return false. And we'll start off next by setting a publish package variable to false, and create an API directory if it doesn't exist already at the same path that we're running this at. So our next bit, we're going to say if the hash folder, so we're going to call that function, is hash folder on the API directory. So if we look inside the generated source API, we have API client and model. We'll run once for API, once for client, and once for model, and we're going to store it into that API folder that we created above as API state, client state, and model state. If any of those return true, we're going to say publish package is equal to true. For information purposes, we're going to write out the publish package variable, and then we're going to use the set output logging that GitHub has to set a output variable called publish package, and we're going to set it to that value. We're then also going to say that if publish package is true, we're going to add all the files that's in that API directory, to stage them all. We're going to set the global config username to CR system. We're not going to set the email address because it will automatically use the email address that's generated for the agent that it's running on. And then we're going to commit this change using that skip CR piece in the message, which I mentioned earlier up here. So again, this part said that if the message doesn't contain skip CR, then this should run. So by this message containing skip CR, when we commit that state back into GitHub, it's not going to run this build for us, and then we're going to run a git push to push those code changes back into the repo, just so we have it for the next time that it runs. We're able to see if the generated code from the API that comes to us from codegen, if that has changed. If it has changed, we can either assume that there's a fix for or a change for codegen which made the API generate differently, or that Strava has changed their API and that we are actually getting updated functionality compatibility on their side. Okay, so the next bit that we've got here is that we need to push our changes to NuGet.org. So we're going to push the package. We're going to say we're only going to push the package if steps.hash_API. So you can see this step has an ID of hash_API. We look at the outputs and then the publish package variable that we pushed out. And we're going to check if that's equal to true, then this is going to run. At this point, we're also going to inject a environment variable called NuGet key, and we're going to get that from our secrets.NuGet key that we added earlier on. Again, this is going to use the PowerShell shell, and we're going to run a .NET NuGet push. We're going to push everything that's in that packages directory. So again, if we look here, here's our package directory. There should only be one when this runs, because obviously we get a new agent every single time. And then our API key is going to be that environment variable that we're injecting here, and then we're going to push this to NuGet.org. So the last thing that we need to do, well, there's actually two small things that we need to do quickly. I just want to update the README file, because having a random README file looks weird. Let's actually keep that name. There we go. So we're going to say the Strava Net5 library generated off Swagger for purposes of a demo. This path should be the path that we get for our badge, so we'll just add that little badge on there. And then we want to make sure our get ignores are set, so we don't add all this gump into source. So we're going to ignore the G folder, which is where our SwaggerGen stuff gets generated into. We're going to ignore the bin folder and the obj folder, which both get created as part of the .NET pack stuff. Our package folder we're going to ignore, because that's where our packed package lands in, so we don't want that in source. Any files that contain out dash we're going to ignore, so that would be our out dash config, and our out dash for our CS project will get ignored. Any of our code fixes we're also going to ignore, because those get created every single time. And then anything that's got a .temp, so if we do later make extra little bits and pieces here, we can call them something .temp, and that'll automatically get ignored as well for us. Okay, so this should all work. So we're going to go here, let's take a quick look at these files. They all look good, and it's a hidden hope. Control enter to commit that, and we're going to push this. I believe we haven't made any changes on the GitHub side, so we shouldn't need to do a pull there. If we go and look in GitHub now, we switch to actions, we can see action has kicked off already for us. As you can see, there's hidden hope. If we look at this build, it's currently running, so it's at the step at the moment where it's running that the codegen. It's run our code fixes already. It's busy setting up .NET Core, or .NET 5. We're now busy running through the package API. And when that's done, should be fairly soon, we're going to run over the hash quickly. And the hash failed because, oh, I didn't call that demo, my bad. So let's quickly jump back over to our environment here, and I'm going to go back to hash API, and I didn't call that demo, I called it data. So let's go hash. So this is what happens when you hidden hope, I guess. There we go. So we actually want to find that inside a data folder, not a demo folder. So say updated demo to data, and we'll commit that quickly. and then we'll push that to GitHub. And because we've pushed another change, that will again automatically kick off our workflow. Because we've told it any pushes to main, it should automatically trigger on. And again, quickly run through the .NET setup. The rest of it's on the package already. I love how fast GitHub Actions is. It just feels like such a great experience for me. The package should be done quickly, and this time the hash API should work as we expected it to. So it should shoot through that method. You can see there it said package. Oh, it's gone. So you can see it said publish package is true. You can see, as I mentioned, it would have a generated email address. You can see it's runner at fv-az, lots of stuff. That's the name. It committed this. You can see it created all three of those files, and that commit was pushed up. And you can see here that our push packages ran, and this did actually push our file up. It's just giving us a warning saying obviously that key does expire in 1 day, and it did create our package. So if we go and look in our repo quickly, so obviously as you saw, this did push, well, it says it pushed changes. If we look at our actions, you can see that no workflows kicked off, as you would expect, because we've told it not to kick off saying if it contains skip CR. If we go look at skip CR, you can see that it's got the SHA-1 hashes of each of those files stored so that we are able to see what those look like. And the reason that I've gone with this approach of storing each file's hash is so that just over time, if we had to look at the state, we can see that potentially the slat long model had changed, or maybe something changed in the client, or maybe inside one of the APIs, instead of it just being there was some change in Strava, which obviously if you're debugging something going weird in your application, it's a nice way for you to see what's going on there. Okay, so if we go and look now at packages, we should be able to see a package which will probably show us unlisted at the moment. There it is. So there is data.strava.net. It was the second package that was published on the 2nd of the 2nd, 2021. Our description as we would expect it. Currently the status of this is validating, but very soon that will switch into being published. You can see our dependencies that we specified, and you can see that this is a .NET 5 package. So let's just give that some time. We'll refresh a bit, and then you'll see that that'll switch, and then you'll be able to actually pull that down. So I'll probably end up switching this package to unlisted, but if you had to go to this URL, it should still show you the package. You just won't be able to search for it directly. Okay, thank you for watching this video. I hope you found some of it useful. If there's some insights into what GitHub Codespaces is, maybe that the fact that you can use Docker inside Codespaces without having to install that all on your machine, which is one of the great powers of it. So in this case, if I had the patience, I could have just connected to this with my phone. It might not have looked that great with me typing on my phone, but it probably should just work on your phone. I haven't tested that, so if it doesn't, don't say, hey, Gordon said, but it doesn't. But yeah, I mean, it uses Chrome web browser, any browser for that matter, should work. And yeah, like I said, hope you enjoyed the video. If you have any questions, leave them down in the comments. You can catch me on Twitter or visit my profile page, which is beaming.dev, to see where else I am on the internet. Cheers.